Okay, so in this video we're going to look at how to calculate the derivative of sine and cosine functions. So basically, if you have y equals sine x, what would the derivative be? And if you have y equals cos x, what would the derivative be? Well, and again, I do want to preface this video like all of them. This does not replace the classroom experience where we would be working in groups, we would be looking at diagrams, we'd be looking at software, we'd be collaborating to see why exactly these definitions I'm going to show you work. These are meant as tutorials to help you. So what we want to do, we're going to look here. This is how I like to look at it. When I have a function y equals sine of u, and I'm going to explain what that u is in a minute, the derivative is going to be u prime cosine of that u. When I have a function that's presented as y equals cosine of u, the derivative is going to be minus y prime sine u. So I'm going to show you how that works, but this right here, this is what we're going to use to help us with these derivatives. So I'm going to go back to y equals sine x. So this u we're talking about is the function that comes right after the last letter of the sine abbreviation. So in this case, u is x. So I need u prime. Okay, that's what my definition says. So the derivative of that is 1. So when I go to write the derivative, I use the definition. It says y prime, so I got that's 1, times, and I'm going to rewrite a cos of that same u, which was x. And of course, 1 times cos x is just cos x. Now we go over to the cos, so y equals cos x, same idea. So find that u, that's going to be the function after that s in the cosine abbreviation. So it's also x, so I can just use the ones I have here. Equals x, u prime equals 1. So now when I go to rewrite the derivative, this one you got to be careful, but you would have this definition with you. Minus y prime. So y prime was 1, so it's going to be minus 1 times sine of that same u, which is x. So it's all about, you're going to learn how to use that definition, but you need to establish what that u function is, because you're going to take that derivative and you're going to have to use both parts when you rewrite the derivative. Now these are going to come in handy because we're going to have to take the derivative of y equals sine x quite a bit. So the more we do, the more we'll come to realize, hey, that's cos x. Same thing, derivative of cos x. The more we do, we're going to come to realize that's just minus sine x. But even if you miss that, that's okay. You can go through this process. So let's look at a few more examples. All right, how about this one? Y equals sine of x squared. Let's establish u. So u is x squared, so I'm going to go over here, take the derivative. Now rewrite it, y prime. So because we had a function of sine, it's going to be 2x, which is u prime times cos of the same u. Okay, now let's look at this one. How about, well, why don't we get, why don't we have a little bit of fun. So what about y equals x sine x? So because you have two functions of x, you're going to have a product rule here. All right, great. I'm going to set up my 1, 2, 3, 4. 1 is x. 2, derivative of that is 1. 3 is sine x. Now, at the beginning of the video, I showed you how to take the derivative of sine x. So I'm just going to remember that's cos x. Oops, sorry about that. Oh, it's not cooperating, so I'm going to have to move over here a bit. I apologize for that. Okay, now we are ready. Y prime. So 1 times 4, that's going to be x times cos x, and 1 times sine x. Now we're going to add, of course, sine x. So again, when we use the product rule, we like that 1 times 4 plus 2 times 3. Okay, now if you're thinking of factoring something out, like you have an x here, but this right here, this cos of x and sine of x, you can't touch that because those are part of the cosine and the sine functions. You'd only be able to factor out any function part that's multiplying those. So here I had x, but over here it's just 1, so there's nothing common to factor there. How about this one? Y equals sine squared x. Okay, so when we look at this right here, I'm not going to take the derivative yet. This right here is actually another way of writing y equals sine and the whole thing to exponent 2. Once we rewrite it like that, excuse me, once we rewrite it like that, this one is set up for the chain rule. So chain rule, because you got this function raised to a power, so we know chain rule says that 2 multiply out front, which is just 1. Now remember that part of the chain rule, you're going to multiply by the derivative of that function that was raised to the power. So in this case, it's sine x. And again, we saw what the derivative of sine x was. It's cos x. So now, this one here, we are finished. So 2, I'm just going to rewrite it like this, 2 times sine x cos x. All right, moving right along. I'm going to do one more example with you. So how about this one? Y equals cos 1 plus x squared. All right, let's establish that u here. So the u is 1 plus x squared. So u prime would be 2x. So remember that definition, you're going to have that handy when you're working on these, is negative u prime, which in this case would be negative 2x, sine of that same u. So again, when you're taking the derivative of sine and cos functions, you are going to use those definitions that I outlined at the beginning. And the key, I think, is establishing what that u function is, like we did here, taking the derivative of that u prime, and then taking these two pieces and rewriting the derivative with that definition now that you have your u and your